In the quiet, vast darkness of the cosmos, something highly unusual is unfolding within the constellation Orion. One of the most prominent stars in the night sky, Betelgeuse, famed for its immense brightness and colossal size, is exhibiting strange and uncharacteristic behavior. Long regarded as one of the most recognizable red supergiants visible from Earth, this celestial giant has begun behaving in ways that have left astronomers both fascinated and puzzled. For centuries, Betelgeuse has served as a beacon in the shoulder of Orion, known not only for its reddish hue but also for being one of the few stars that can be seen with the naked eye to vary in brightness over time. However, recent events have shifted this star from a subject of wonder to one of mystery. Betelgeuse has begun to dim, pulse, and spin in ways that defy expectations. These behaviors are not fully understood, and they have prompted scientists to pose a startling question. Is Betelgeuse, in its final phases of life, interacting with an unseen, perhaps hidden companion? To understand why this question carries such weight, it's important to consider what Betelgeuse actually is. Betelgeuse is a red supergiant, one of the largest types of stars in the universe. If placed at the center of our solar system, its surface would extend well beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and our neighboring red planet in its fiery expanse. Despite its luminosity and magnitude, something seems to be interfering subtly but persistently with the star's natural behavior. Some scientists believe that this influence may be coming from a secondary body, perhaps another star, concealed from view by clouds of dust and the overwhelming brightness of Betelgeuse itself. This possibility has inspired a wave of new observations and theories that could fundamentally reshape our understanding of how massive stars evolve and die. Betelgeuse has long been known for its erratic light patterns, but in late 2019, astronomers around the world witnessed something unprecedented. The star began to dim significantly, losing up to 60% of its brightness in just a few weeks. This dimming was so dramatic that some began to speculate whether the star was on the verge of going supernova. Given that red supergiants like Betelgeuse are known to end their lives in violent explosions, this wasn't an unreasonable fear. However, deeper analysis revealed a less catastrophic explanation. The dimming was likely caused by the ejection of an enormous cloud of dust, which then drifted into our line of sight and temporarily blocked the star's light from reaching Earth. This great dimming, as it came to be known, wasn't the beginning of the end, but it did serve as a cosmic wake-up call. It showed that Betelgeuse was not as stable as once thought, and that external factors, or perhaps internal events, might be playing a larger role than previously believed. Betelgeuse naturally varies in brightness due to internal pulsations, essentially waves of expansion and contraction that ripple through the star's massive atmosphere. These are expected in stars of its kind and are generally predictable. But one particular pattern caught the attention of scientists, a secondary longer cycle that repeats roughly every 6 years. This rhythmic fluctuation is unusually consistent and cannot easily be attributed to chaotic processes within the star itself. It hints at a steady, repeating influence, potentially the gravitational tug of a nearby but unseen companion. This idea gave rise to a compelling hypothesis that Betelgeuse is not alone. It might be part of a binary system, accompanied by a much smaller and fainter star, orbiting at a considerable distance, possibly around the same range as Saturn orbits the Sun. If true, this would not only explain the 6-year rhythm in Betelgeuse's light, but might also account for other anomalies, such as its surprisingly rapid rotation. To investigate this possibility, a team of astronomers led by Jared Goldberg turned to the Hubble Space Telescope using its ultraviolet spectrograph to search for subtle traces of a hot, faint object hidden near Betelgeuse. Ultraviolet light is particularly useful in this scenario because it can reveal hot, low-mass stars that would be invisible in ordinary optical wavelengths due to the glare of the main star. Unfortunately, the team was unable to confirm the presence of a companion. The surrounding dust and Betelgeuse's brightness made it nearly impossible to observe anything directly. Still, this lack of visual confirmation did not disprove the theory. In fact, it only deepened the mystery. Further observations began to suggest that something, though unseen, is exerting a measurable effect on the star. One particularly perplexing anomaly is Betelgeuse's rotation speed. Given its advanced age and evolutionary stage, it should be spinning far more slowly. Instead, Betelgeuse rotates at a speed of about 5 to 15 kilometers per second, far faster than theoretical models predict. A likely explanation is tidal acceleration. Just as Earth's oceans are influenced by the gravitational pull of the Moon, a nearby stellar companion could be exerting tidal forces on Betelgeuse, keeping its spin rate elevated. These gravitational interactions might also be disturbing the star's outer layers, leading to the consistent 100-day pulsation observed by astronomers. If a smaller star is indeed orbiting Betelgeuse, its presence could be stirring the massive outer envelope of gas and plasma, causing periodic changes in brightness, shape, and even mass loss. Interestingly, this wouldn't be a rare arrangement. Most massive stars are born not in isolation, but as part of binary or multiple star systems. A solitary red supergiant like Betelgeuse would be an exception, not the rule. This makes the idea of a hidden companion even more plausible. Some researchers have gone a step further, suggesting that Betelgeuse may have merged with a smaller star in the past. Such a merger could account for both its mass and rapid spin. However, this theory doesn't fully explain the ongoing, periodic changes still observed today, which seem to indicate a continuing external influence rather than a one-time event. If Betelgeuse does have a stellar companion, it could be significantly altering the star's end-of-life behavior. Red supergiants like Betelgeuse are known to shed enormous amounts of material in their final phases. These mass ejections form vast clouds of dust and gas around the star, features that have been documented around Betelgeuse in recent observations. A close orbiting companion could be responsible for triggering these ejections by gravitationally disturbing the star's extended atmosphere. What may appear to be sudden, violent expulsions of matter could actually be regular responses to the gentle but persistent pull of a hidden neighbor. Understanding this interaction could offer crucial insights into how supernovae form and behave. If astronomers can confirm the presence of a companion and trace how it influences Betelgeuse's light, mass loss, and rotation, they may be able to better model how red supergiants evolve and ultimately explode. It could transform how we interpret data from other dying stars across the galaxy. For instance, interactions with a companion might determine not only the timing of a supernova, but also its intensity and the structure of the resulting nebula. This could have profound implications for our understanding of the universe. The physics of supernovae shapes the distribution of heavy elements, like carbon, oxygen, and iron, throughout space. These elements form the building blocks of planets and life. If companion stars play a key role in triggering or shaping these explosions, they might indirectly influence everything from galaxy formation to the origins of life itself. Looking ahead, upcoming observatories, most notably the James Webb Space Telescope, may finally be able to cut through the dusty veil surrounding Betelgeuse and detect the elusive companion, if it exists. Its infrared instruments are ideally suited to spot faint objects hiding in dusty regions of space. Meanwhile, Earth-based telescopes will continue monitoring the star's light variations, spectral shifts, and 6-year pulsation cycles. If these patterns remain consistent, they could provide additional data points that bring us closer to confirming the presence of a second star. What makes this celestial investigation so captivating is that it is unfolding in real time, with a star visible to the unaided eye. On any clear night, one can step outside, look up at the Orion constellation, and see Betelgeuse shining faintly with a reddish glow, an ancient, volatile star carrying secrets within its flickering light. It is a rare opportunity to witness cosmic transformation as it happens. Whether Betelgeuse is being influenced by a hidden companion, bears the scars of a past merger, or is undergoing some entirely new kind of stellar evolution, scientists are closer than ever to decoding its true nature. This is not just the slow decline of a dying star, It is an unfolding astrophysical puzzle, rich with possibilities. When Betelgeuse finally reaches the end of its life, it may do so in a way that redefines what we know about how stars live and die. Its final act, whatever shape it takes, may be among the most spectacular and scientifically revealing stellar events in our lifetime.